Hi there. Today I'd like to share a topic that is a part of organic chemistry, or specifically the part of natural products, that is called terpenes. This is MD Hasinul Babu. I'm studying at Department of Chemistry, University of Chittagong. Today I'd like to share this topic, terpenes. Actually, how can you define this term, terpenes? Terpenes means, you can say, the organic hydrocarbons, or the part of natural products. Those are originated from plant terpentyl oil and essential oil with C5 and carbon units, having pleasant smell and isomers of molecular formula C5H8N. Those are known as terpenes. Today I'd like to share the topics that is called, you can say, terpenes in detail. We know that about, in addition to alkaloids, 2000 plant originated compounds and also possess medicinal properties. Those are known as terpenes. And the plant that is called pine tree. From pine tree, we can extract terpentyl oil, and the molecular formula of terpentyl oil, you can say C10H16. And if you'd like to know about this kind of things in detail, we know that about essential oil. We observe pleasant smell in fruits, flowers, leaves, stems, barks, and roots in most plants. Stem Stem distillation or solvent extraction of these plant parts yields a pleasant smell oil. Used as a scent, we know that about there are lots of, you can say, perfume industry. Those use this essential oil for manufacturing scent, and many pharmaceutical industry in our country, they use this essential oil for synthesizing medicine, or different kinds of dye industry, though, to produce color or dye, they use this kind of essential oil to produce color or different kinds of dye. Active volatile compounds, we know that about active volatile compounds among essential oils contain 5 carbon units, mainly consist of carbon and hydrogen, and those are unsaturated, not saturated. Unsaturated means those compounds must contain carbon carbon double bond or triple bond, etc. And these compounds, essential oil, are not aromatic. That means it will be, most of the cases, it can be, you can say, aliphatic. It's not the aromatic. It does not fulfill the feature or requirements of aromatic compounds. That's why essential oils, those we observe in fruits, flowers, leaves, stems, barks, and roots in most plants, they are not aromatic. And the next one, those are known as, you can say, terpenes. I have already told you what is terpenes. Terpenes, aromatic hydrocarbons or organic hydrocarbons originated from plant terpentyl oil. And at the same time, if you'd like to say that, with, you can say, molecular formula C5, and that means, you can say, it contains minimum isoprene unit. We know that about, in case of isoprene unit, actually total number of carbon is 5. That's why we can say that in terpenes which contain C5 and carbon units, C5, or you can say C15, uh, C10, or you can say C20. This kind of ratio should be maintained in case of terpenes. The terpenes, which contain pleasant smell, and which should be isomer of molecular formula C10H16 or C5H8N. Those are known as, you can say, terpenes. If I share an example of terpenes, we can say that limonene. It's a limonene. Actually, if you'd like to say that it's a total number of carbons in this specific compound is 1 2 3 4 5. 1 2 3 4 5. Total number of carbon is 5. 1 2 3 4 5. 1 2 3 4 5. That means in this limonene, this is an example of, you can say, terpenes, and it contains two isoprene unit. That's why we can say that it's you can say it's a uh, terpene. Actually, we have already told you terpenes not aromatic. Actually, this limonene compound it's not aromatic because uh, there is a single double bond in the cycle, but there are not, you can say, conjugated double bonds. It does not follow the Hakel rule. That's why we can say that limonene is not aromatic compound. And we know that about terpenes are unsaturated. Actually, this limonene compound that contains carbon carbon double bond here, this compound that contains carbon carbon double bond. That's why we can say that uh, this is a carbon carbon double bond, this is another carbon carbon double bond. That's why we can say that this compound is unsaturated compound. And the next one that is called, you can say, alpha pinene. That is look like the structure of methyl benzene, but it contains just single double bond. But it contains, you can say, bicyclic form in the internal portion of this compound, but it is not aromatic compound because it just contain a single double bond. But it does not contain, you can say, conjugated double bond or alternate double bond in the ring. That's why we can say that it does not follow the Hakel rule. That's why we can say that it's not an example of aromatic compound. It's non-aromatic compound. Along with this, we can say that this compound, actually it's a unsaturated compound because this compound we are seeing that actually it contains carbon carbon double bond. That's why we can say that it's a unsaturated compound. That's why we can say that limonene and alpha pinene are example of terpenes. And these two compounds, those are originated from, you can say, plant. And alpha pinene, that can be originated or extracted from pine tree. Limonene, it also extracted from plant. Actually it's a plant originated terpene, actually you can say. And molecular formula of these two compounds are, you can say, cetane is 16. That's how we can say that limonene and alpha pinene are example of terpenes. And the next one, if you'd like to say that, that is called, you can say, terpenoids. Terpenoids. Terpenoids means, you can say, the compounds or the natural products which are originated or oxygenated derivatives of terpenes are called terpenoids. As for example, we know that about alcohol, that is a, you can say, oxygenated compound or derivative of terpene or aldehyde or ketone. As for example, we know that about terpenes. Terpenes are known as, we can say terpenes are organic hydrocarbons, and their oxygenated derivatives are terpenoids. As for example, we can say that citral, that contains a aldehydic group. That's why we can say that this portion, it's an oxygenated derivatives of, you can say, terpene. That's why we can say that it's a terpenoid. Specifically, we can say that it's a terpenoid because it contains oxygenated derivatives. Citral. Uh, if you'd like to say that this compound, that is a citral, it contains two double bond. Here is a here is a double bond, here is another double bond. And this total group is called, you can say, isopropylene group. This is a, you can say, methyl group. So we can say that citral is an example of terpenoids. It contains, you can say, CH group and isopropylene group. And you can say this is the overall structure of citral. This is an example of terpenoids. If you uh, say the occurrence of terpenes, we can say we occur the occurrence of terpenes are, you can say, plant kingdom. And we can extract terpenes from fruits, from flowers, from leaves, from stems, from, you can say, barks and roots. And general properties, if you look into the general properties of uh, terpenes, we know that about terpenes, most of the cases they are colorless, pleasant smell, and boiling point less than 200 degrees Celsius, soluble in organic solvents. Many are optically active, have one or more double bonds, and hence highly reactive. shows addition reactions with we know that about nitrosyl chloride and nitrosyl bromide. If you give an example, it's a carbon, it's another carbon, it's a carbon carbon double bond. If you give an example, it's a, you can say it's a hydrogen. So we can draw a compound that is called, you can say, ethylene or ethene. It's an example of alkene. We would like to show the addition reactions of alkene. We know that about you can say terpene or terpenoids. Those contain, you can say, carbon carbon double bond, at least one carbon carbon double bond, because we know that about terpene or terpenoids are unsaturated compound. We would like to add nitrosyl chloride, and ooh, it's a nitrosyl, it's a chloride. If you'd like to dissociate, if you'd like to break down this compound, we know that about chlorine is more electronegative, that will, it will be chloride, it will be nitrosonium ion. If you if you added this nitrosyl chloride into carbon carbon double bond, we know that about when a single ball breakdown here, one hand will be free, another one will be free. We'd like to remove this bond. We'd like to remove this bond, and we would like to add, we can add, we can say here nitrosyl, it's a nitrosonium ion. Here we can add Cl. In this way we can add, you can say, uh, nitrosyl chloride to carbon carbon double bond containing alkene. We know that about uh, terpenes, those contain carbon carbon double bond. Those contain carbon carbon double bond, those are known as, you can say, uh, terpenes, because terpenes are unsaturated compound. That's why in case of terpenes we will be able to add nitrosyl chloride or nitrosyl bromide. And we know that about terpenes shows addition reaction with nitrosyl chloride and nitrosyl bromide. And we also know that terpenes, terpenes shows polymerization reaction and shows diacetyl reaction, because most of the cases we will be able to see that some terpenes or terpenoids contain carbon carbon double bond, and those are conjugated, you can say most of the cases you'll be able to see terpenes will contain conjugated dienes, and due to the presence of conjugated dienes they show diacetyl reaction. We know that about in case of diacetyl reaction, one diene and one dienophile are present, and most of the cases internal diacetyl reaction can be occurred in case of diacetyl reaction. In case of you can say natural products or terpenes. If you'd like to give an example, that is called, you can say, terpenoid or hot are terpenoids. The compounds which are the oxygenated derivatives, or you can say aldehyde, ketonic, or you can say uh, alcoholic derivative of you can say terpenes, those are known as terpenoids. When you'd like to you can say uh, process, when you'd like to pass these terpenoids on thermal decomposition chamber, those on thermal decomposition produces isoprene. We know that about in case of isoprene unit, we know that about at least one carbon, or you can say five carbon atoms are present, 1 2 3 4 5 in this specific compound. If you'd like to give a number, a trivial numbering system, we could know that it's a number one, it's a number two, number two center, it's a number three center or carbon, it's a number four center. So we can say that here are, you can say, four atom, and here is another carbon atoms is present. Total number of carbon is five. We know that about in case of isoprene unit, carbon five, and hydrogen carbon five units are present. And in this specific in this portion, you can say that this carbon atom attached with this carbon atom by double bond. That's why this carbon atom, in case of this carbon atom, actually in this carbon atom, there are two free hydrogens are available. In this carbon atom, one free hydrogen are available. In this carbon atom, three free hydrogens are available: 3, 1, 4, 4, and 2, 6. And in this carbon atom, two hydrogens are available. That's how we can say that C5H8. That is an, you can say, molecular formula of isoprene unit. And we can say that one isoprene unit that contains, you can say, uh, total number of carbon is C5 and total number of hydrogen is H8. That's so we can say that it's a isoprene unit that contains, you can say, C5H8 molecular formula. And this is the, you can say, overall things of isoprene unit. And when you'd like to, you can say, pass a terpenes on thermal decomposition chamber or thermal decomposition process, then obviously terpenes will convert it into isoprene. We can say that this compound is, you can say, it's a 2 methyl, because this methyl branch is attached with this 2 numbered carbon. That's so we can say that it's a 2 methyl, you can say it's 1 3 butadiene, because in the main chain, you can say in the parent chain, total number of carbon is 4. That's so we can say that our word root will be, you can say, butane. And you can say in the position 1 and 3, 2 in, that means 2 in is present. That's so we can say that it's a diene. That's why the overall name of this compound will be, you can say, 2 methyl 1 3 butadiene. That is the, you can say, chemical name or epic name of isoprene unit. We can found this isoprene unit by means of uh, thermal decomposition process of terpenoids. So guys, this is all about today. Thank you for watching this video. Stay tuned, stay connected with this channel. Hit the subscribe button and press the bell icon for watching this kind of videos. If you'd like to know about in-depth knowledge, if you'd like to get insights about, you can say, organic chemistry or chemistry, then this channel is really helpful for you. You will get such kind of amazing videos in your upcoming, in my upcoming, you can say, journeys. So guys, that's all about today. Thank you for watching this video. Assalamu alaikum.